A rough plane, so friction, is inclined to the horizontal at an angle alpha, where tan alpha is 3/4. So if tan alpha is 3/4, let's just deal with that first. So we've got an angle alpha in a right angle triangle. Let's have alpha up here. TOA, tan alpha is opposite over adjacent. So the opposite is 3, the adjacent's 4, and it's a 3-4-5 triangle. So using a Pythagoras triple, the hypotenuse is 5. So we know what cos alpha, we can just make a note, cos alpha is adjacent over hypotenuse, which is 4/5, and sine alpha, opposite over hypotenuse, 3/5. So we've got friction, we've got the angle alpha, a small block, mass 5 kilograms. It's held in equilibrium by a horizontal force of x newtons, which is shown in the diagram. The force acts in a vertical plane which contains the line of greatest slope. B is modeled as a particle. The magnitude of the normal reaction is 68.6 newtons. And find the friction and the direction of the friction. Okay. So let's draw some forces on the diagram. So going straight down is the weight. So weight is mg, so the mass times gravity. We've got perpendicular to the plane. We've got the normal reaction, which we know is 68.6 newtons. We know we've got a friction force, but we don't know which way it is going. So I'm going to redraw this x as well. So I'm going to redraw x. I just prefer it to be going in the direction it's going. So that's x newtons. And we don't know which way friction's going. It's either going up or down the plane. I'll just draw it in this way, friction, but I don't know if it is actually going that way. If I get a negative answer for friction, that will mean it's going down. And we've got, I'm just going to draw a tilted axis, and then the angle alpha will be this angle in here and this angle here. So there are all of our forces. Now we can just work things out. So we can do forces perpendicular to the plane. So forces perpendicular to the plane. So forces up. So perpendicular to the plane. The force is up 68.6 is equal to the forces down, which is 5g cos alpha and x sine alpha. We know what cos alpha and sine alpha are, so we can substitute them in. So 68.6 is cos alpha is 4/5. 4/5 of 5 will be 4. So that'd be 4g plus sine alpha is 3/5. So 3/5 of x. So if we do 68.6, take away 4g, times 5, divide by 3, we get x. We may as well do that. I'll use the calculator. I don't want to do too much in my head. So 68.6 minus 9.8, and then times 5, divide by 3, 49. We get x is 49 newtons. we're interested in the friction. So we can do the forces in line with the plane, parallel to the plane. So friction plus x cos alpha. X is 49, so 49 cos alpha, 4/5, is equal to 5g sine alpha, 5g times 3/5, which would be 3g. So friction is going to be 3g, take away 4/5, 49. So 3 times 9.8, take away 4/5 of 49 is minus 9.8. So that means friction is 9.8 newtons acting down the plane. So the magnitude is 9.8 newtons and it's acting down the plane. So that's part A done. The horizontal force of X is removed and the particle B is going to move down the plane. So friction's going to change. Given the coefficient of friction is 0.5, find the acceleration down the plane. So now friction is going to be going up the plane. X is removed. So we're going to have a new set of forces. So for part B, so we still have the weight, which is still 5g. Friction is going to go this way, and I'm going to put mu r. And r will be different, so r is something we're going to have to work out. And then the angle alpha will be in here. So now we can say that r is going to be 5g cos alpha, which is 4/5 of 5g, which is 4g. And then we can look at F equals ma. So the forces, the resultant force is 5g sine alpha, 5g times 3/5 minus mu r, which is 0.5 times 4g. That's the resultant force. That equals ma, which is 5a. So we've got 3g, take away 2g, which is g equals 5a. So a is going to be 9.8 divided by 5, which is 1.96. 1.96 meters per second squared.